Hello everyone, how are you? Good morning, Mariam. Good morning, um, Alia. Good morning, Lee. Good morning, Muhammad Sharif. All right. Good morning. Siapa lagi? Juwaria. Good morning, Louis. Good morning, Nurul. Good morning, Muhammad Rafiq. Okay. Good morning, Nur Husna. Good morning, Farzana. Good morning, Izatul. Good morning, Aziza. Right. Good morning, Khairul. Okay. Good morning, Nur Farhaniza. Good morning, Siti. Good morning, Hajar. Good morning, Hawa. Good morning, Anis. Good morning, Sajwan. All right. Good morning, Tarishini Raja. All right. Oh, many. All right. So now we continue our subject. All right. Make sure you on your e-learning, right? Because we have something is okay to deal with, and then we make sure you also have your handphone because there is a confirmation, okay, about your attendance today. Okay, you can get your attendance, okay, through the Telegram. Okay, e-learning to get more material. I will upload, okay, many material to make you understand for this subject. This is very interesting subject. You know why? Because this deal with the simulation, deal with the solving problem with a very fast and very accurate, all right? And then there is approximation between the analytical solution that you learn from calculus and the numerical, where numerical is more on the approximation solution, but the error is not too much, all right? It's around, you can control the error, all right? Come on, we repeat again. When we are using 4 decimal places, all right, so based on your calculator, you need to, okay, make sure that the acceleration, okay, or conversion criterion is 0.0004. It's a 4 decimal place. 0.0005. Right. So you learn already in numerical 1. I just want to remind you because after this, I will ask you how to control the iteration using maybe we are using maybe Gauss-Seidel, Jacobi method, all right, or Bosch, Bushford, Moulton. Okay, when we control the iteration by using the epsilon. Don't forget. All right. So just repeat the epsilon. All right. So now let's we continue our subject. All right. Good morning. Who are coming here? Okay. All right. So good morning, Sabrina. Good morning, Muhammad. Okay, Nakiuddin. Good morning, Azizah. Now 58. Okay, watching the class today. Thank you very much. Okay, we are going to confirm your attendance with a small, okay, with small exercise, but it's really informative to get along with this subject. All right. Okay. All right. So now we continue. Okay, we continue. All right. Okay, I focus my subject. Okay. All right. around you, around this room. You have Y. Y is a temperature behavior. It depends on the space, okay, X in this room. All right. The temperature behavior also is depend on the evaporation in this room. All right. The aircon. Okay. For example, I'm using aircon, so it's depend on the how fast, okay, how decrease the aircon, okay, temperature. So the temperature in this room Y is depend on the X. X is the size of this room, and Z. Okay, and Z. Z is a how fast the temperature decrease because of the aircon. So you have two equation. Y, okay, is also temperature. Z is also the temperature, okay, influenced by the aircon. So you have a double. You have twin equation of the ODE. So in this case, we call as a system. We call as a system of the first order derivative. We are still using first order derivative, kan? All right. So in this case, we deal with the initial value problem. Go to chapter 8. We always write y not equal to alpha, z not equal to beta, and x not equal to 0, for example, y not equal to 0, for example. All right. So we always deal with the initial value theorem. Go to the chapter 8. All right. Go to the chapter 8. Okay. So now, okay, let's refocus. Okay, let's Okay, Aziza said that I can't hear you, doctor. All right, so let's we continue. Okay, some not okay, hear me. Okay, I think now you can hear me now. All right. Okay, so now I think you can hear me. All right. Okay, here now. Okay. Okay, now let's we continue. So, for example, just now is what we call as a COVID-19, okay, COVID-19 in our area, in your area, okay, Intan, I don't know what happened to your area. Is it increasing? In my case, it's increasing, all right. I don't know why, because people still not keeping the SOP. So X is an increasing of the COVID-19, okay. COVID-19 problem is depend on time, all right. They claim they are convict, they affected from the convict death because of convict. So X is a increasing of the COVID-19. Y is how we keep the awareness about the SOP to keep distance between us, all right. And X is just now is how we investigate the increasing of the convict depends on time. Y is how you keep the SOP in your area, all right. And you have to see here when T is equal to 0, so the number of convict is equal to 1. X is equal to 1. Second is when the time is equal to 0, the awareness about the convict Y is equal to 2. So this is a way how we write the problem in ODE, ordinary differential equation. Actually, we can also write in the partial differential equation, but now since we are under ODE, so we transform the equation to ODE. All right, so now we continue. So I just want you to know how important the ODE, all right, to solve your problem. For example, dm over dt equal to negative L1m and dt, the first derivative d respect to t equal to negative L2 d plus L1m. Okay, so how we relate this equation? For example, okay, I know you are watching me too much. Okay, started from last week, this week, so your eyes become weak after 2 hours. Okay, because you need rest. All right. So M is an eyes movement of your eyes movement, left, right, up, and down. All right. It's depend on time. The eyes movement is depend on time. If time is too much, okay, for example, driver, programmer, all right, people looking at the computer, so the eyes become weak and weak. All right. So the eyes is depend on the time. Okay. When time equal to 0, the eyes movement is equal to 1. For example, L1 is any parameters involved where we call as a constant. For example, the eyes is depend on the because every person have their different eyes movement. All right, different eyes movement is depend on the strength of your muscle around the eyes. So D is a strengthness of the muscle around the eyes. It's also depend on time. So here, the muscle stress around the eyes is D. It's depend on the time. It's depend on the time. This is a couple or twins or integrated, or we call a system of ODE to represent eyes movement. All right. So now, now we go to the higher order ODE. Okay, higher order ODE. For example, here, we have y prime prime x plus y prime x plus y equal to x. Okay, where x not equal to 0, y prime 0 is equal to 0. So how to govern into system of the first order derivative? This is my question, because we want to integrate the first order ODE, and number 2 is a system of the ODE. So we have a system, and then we write this one into two system, into what we call two equation of the ODE, or sometimes we call as a system of first order ODE. This is how we pronounce. It depends on your understanding. All right. So now, since we have a second order derivative here, second order derivative y prime prime, so we downgrade to the first order derivative. You look at the Euler method. Euler method, we are using first order derivative. Am I right? Okay, so now, how you govern? Now, you assume z as a first order derivative. All right? And z prime is what? Is a y prime prime kan? Is a fxyz, where we assume that zx naught equal to y prime x naught, which is given here. Y prime 0 is equal to 0. So we put as a z, we put as a z, z x naught equal to y prime x naught. And then, we have two equation now, where y prime is equal to z. Y prime is equal to z, z prime is equal to y prime prime. All right, y prime prime. So this is instead in your mind, how I convert. Just very simple. I just assume z as a y prime. Right? All right. What is a y prime? Is a fxy. You still remember, in the Euler Method, chapter 8. All right. So that is inside your mind. So z prime is a fxyz. All right. Now we go to the second step. Obtain system of first order equation in the two equation of EDE. What we call as a system, kan? All right. So we can obtain as what? As z prime plus z plus y equal to 0, all right, and y prime is equal to z. So you develop two set of the first order derivative. So you transform already second order ODE y prime prime plus y prime xy equal to x, you can write as a system of the first order derivative, okay, where the system is a z prime plus z plus y equal to x and y prime equal to z. So you downgrade the higher order to the low order from second order of the first ODE, okay, for the second order of the ODE to the two system first order ODE. All right, don't forget your initial condition, because when we deal with the ODE, we always refer to the initial value problem. The initial condition is a z not equal to y prime naught and yx not equal to y naught. All right, so now, okay, all right, so this is my question, okay. So I stop sharing. Why I want to stop sharing? Okay, because okay, I want you to recall again. Okay, recall again. I think I can. I think I can share the link through the chat. Okay, top chat. You just click at the top chat, all right, and then try to answer. When you answer my question, okay, just want to make sure that we are iterative. Yeah, we are iterative, right? So you go to the chat here, right? Okay, you try to click, okay, or I can show you the link for the chat. All right. Okay, try to answer. I give you okay, around 3 minutes. If you can go 3 minutes, all right, to answer the question. I'm waiting you at the link here. Okay. You can also go to the e-learning. Okay. You can also go to the e-learning. Can you go to the e-learning? All right. you can get this link to the e-learning. Try to answer. I'm waiting you. All right. I'm waiting your feedback. I'm opening now. Right. Right. I think I want to share with you the answer. I'm stop sharing. I share with you the answer. All right, very good. Thank you very much. Okay, this is feedback from your friend. Okay, from Lo Wei Han. Okay, you can see here. You can go to the okay the link. Okay, you can see. Very good answer. You can see the answer. Okay, very good. Okay, all right. Go to the link. Get the feedback. All right. Okay. Lo Wei said what that I share with you. Jasmine said what? Okay. Jasmine said that ODE involved. Okay. I know you okay, but try to use your notes, e-notes. Try to use your e-notes. Okay. I don't want you to get any sources. I know it's very easy to get other sources, but try to use your own words, your understanding, and refer to the chapter 8 and chapter 9, which is you learned before in numerical 1. Okay. Okay, come on. There are so many feedback here. All right. Lo Wei said that PDE involved derivative in multivariable. Okay. Otherwise, okay, ODE involves single variables. This is a very, very good result. Okay, I think this is a very, very good answer. This is the first one. Very good answer. All right. So it means that okay, Lo understand that now we are dealing with a one parameter. With temperature in this room is only depends on the size of this room. Okay, or the temperature of this room is depend on the time. We cannot integrate. Like PDE, we can say that temperature in this room depends on size and time, but not for this topic. We are dealing with one parameter. Very good. Okay, very good. Now let's we go to the okay, others one. Okay, right. All right. Okay. So now we continue to others. Okay. All right. Okay. So now we continue. All right. So very good. This is all the answer you can see here. Okay. For example, Nora Tifah. Okay, said that ODE contain only one variable, PDE multi-variable. Very good. Okay, very good. And then ODE contain one variable, PDE contain more than one variable. Okay, very good. All right. So for me, stop sharing. Okay, very good. Okay. All right. All right. So now we stop sharing. Okay, we continue again to our next session. Okay, what is the next session? Okay, we share screen again. All right, we go to our notes. Okay, our notes. Okay, so now how to solve this problem? Okay, since we have first order derivative, okay, and then the set of the ODE. All right, so the question here is uh, okay, the question here is how to solve this problem. Okay, how to solve this problem. All right, so now we go. Okay, now the question here is how to solve this problem. Okay, what is the problem? The problem is ODE. All right, okay. So this my question is how to solve this problem. ODE. So there are many ways to solve this problem. Okay, the first in chapter 8, and you learn about the way how to solve this problem using the Taylor's method, okay, Ranch-Kata method, and then Euler method. All right, so that's you learn. Okay, so today, okay, we are going to learn using two types. The first is a single step. The second is a multi-step, right? Single step, you learn in chapter 8, numerical 1, where you know about solving ODE using Euler method, okay, solving using Taylor methods, and solving ODE first order ODE using Ranch-Kata method. Okay, you learn about the Ranch-Kata method, explicit second order derivative, and explicit fourth order derivative. Okay, this is not considered as a multi-step. This is only considered as a single step. All right, single step. All right. So now, now, I want you know the difference between explicit and implicit. Okay, explicit is a method where you are using the previous grid. Implicit, okay, where you are using the current grid. Okay, the current grid. Okay, for example, the same level, the current values. All right, so now we go to the others, okay, exercise, okay, whether you can understand, okay, what is a difference between explicit and implicit. All right, so you can go to the chat, okay. I hope you go to the chat, okay. Okay. Go to the chat and try get a vote. I want to wait from your vote. Okay. Okay, come on, go to the chat. So you can also okay, wait for a while. Okay, try to go to the chat. All right. So go to the your Telegram. You can try to answer. Okay, try to work. Okay, try to answer this question. All right. Right. Let's vote. Okay, I'm waiting you. Okay. You learn about Jacobi method. Okay, for solving a linear system of equation. Right. You also learn about Gauss-Seidel method to solve the linear system of equation in chapter 2. In chapter 2. So you learn about Jacobi, you also learn about Gauss-Seidel, right? So we can say that Jacobi is a explicit method, and Gauss-Seidel we call as an implicit method, all right? And then you also using the parabolic equation in chapter 9, all right? And then you solve the parabolic equation using Cran-Nicholson. So Cran-Nicholson is integrated between explicit and implicit. So we call Cran-Nicholson as a semi-explicit and semi-implicit. All right. So in this case, okay, what is an explicit and implicit? I'm waiting your answer. I give you some example already. Okay, you try to relate what you learned, okay, in chapter 2 about solving the ordinary differential or solving the linear system of equation using Jacobi and Gauss-Seidel. All right. Okay, Jacobi is a explicit and Gauss-Seidel we consider as a implicit. And then in chapter 8, you solving chapter 9, you are solving parabolic equation using Cran-Nicholson method. So Cran-Nicholson is a semi-explicit, semi-implicit. All right. So now let's answer. Okay, the question: what you understand about explicit and explicit and implicit? Okay. Now I love if I can share with you, okay, some feedback from your friend here. I want to share with you, okay, the feedback here. Okay, I really okay appreciate your answer because okay you still remember chapter chapter 2, chapter 9. All right, okay, so you can see here. All right, you can see here. Okay, your friend said that. Who is this? Okay, let's we go. Okay, let's we go. All right. The first one, we go to the first one is Farah said that implicit calculate the system status at the future time from the current system. Implicit calculate the system status at the future time from the present or the future times. Okay, very difficult to understand, but I understand. Okay, what Farah said. All right, I understand. Thank you very much. Okay, and then we go to the another one is Nur Izati said that Jacobi is used for value obtained from the previous step. Gauss-Seidel is which is implicit, always applied to the update value during iteration. Very good. Okay, answer. And then Farah want to express again about the explicit calculate the system feature. Okay, she is repeating. Okay, so now I want to get the Very good answer. All right, so go to the Nur Syafiqah. Nur Syafiqah said the explicit parameter are calculated based on the previous level. Implicit parameter, okay, depends on the current or the same time level. Okay, very good. What level? Okay, time level, okay, or grid level, iteration level, which one? Okay, I'm going to explain. All right, so now I want to get a feedback from Muhammad Asri. Muhammad Asri said that explicit a system for the future time. This one is same as Farah. Okay, this I can detect. This is a copy. Okay, it's a copy. I want more on your words. Okay, what you learn in the numerical one. Explicit means that something is stated with the clearly, while explicit is not. Okay, it's like surat cinta lah. You know, surat cinta is implicit. Alright, after kahwin, you see that explicit means that you are no implicit. Implicit ni tak tersirat. Explicit ni tersirat, you know. And then now, implicit use a current value. I'm still researching a good words. Okay, I know this is all correct, but I want you to relate whatever you learn from the previous. Okay, Jacobi, okay, y, the value of x, this one you're using x is depend on the x1 is depend x2, x3 is depend x1, iteration 1 is depend, iteration 2 is depend to iteration 1, iteration 1 is depend the initial value. So it all depend on the previous step, previous iteration, previous time, all right? However, implicit, you are using current, okay, current iteration or current grid. All right, for example, you see Gauss Seidel, to get y1, okay, they need to use y3. So where is y3? All right, to know what is to get y2, you need to get y1 at the previous iteration. Is a current iteration, not previous. All right, so you are using updating value at the same level of the iteration. So that's we call as a implicit. Explicit, previous, so much depend on the previous parameter. All right, so this is a basic. Thank you very much. I want to get some more feedback. I'm getting more feedback from you. Okay, right, when you write you'll know. Okay, when you write you know. All right, so all correct. Okay, for example here, Nur Asha said that previous, doctor, explicit use a previous, implicit use a current. Okay, this is a really really understand. Okay, and then now, okay, I'm stop sharing. I want to continue again. Okay, you understand what is the implicit? Okay, what is an implicit? Okay, and what explicit? All right. So that's you set in your mind. Okay. Because now I want to apply the explicit method first. Okay, and then continue with the implicit method. I'm using hybrid. Okay, but at this moment I'm using explicit first because I want to apply Euler method, Taylor method, and Ranskata method, where we can get in chapter 8. All right, so that's we call as a explicit. Okay, and single step. All right. Okay, so now I'm stop sharing. I want to share my notes again. Okay, to make sure that you understand the difference between explicit and implicit. Yeah, explicit and implicit. All right, very good. Okay, I hope the rest also understand the difference between explicit and implicit. Now, okay, let's go to this. Okay, Euler is what? Is a first order. Okay, Taylor is what? Second order and third order. Ranskata is what? Second order and third order. All right. So now, this we learned already in chapter 8, numerical 1. Okay, now we are in the multi-step strategy to solve the first order ordinary differential equation using a few methods. Okay, the first is Adam-Bashford method. All right, Adam-Bashford method, there are a few steps. There are 2 steps, 3 steps, and 4 steps. Okay, Adam-Bashford. Adam-Bashford is come from the derivative, okay, of the function polynomial, okay, and then this is considered explicit because it's same as Euler, okay, same as Taylor's and Ranskata, all are explicit. Okay, so now we want to improve Adam-Bashford method. We call as a Adam-Moulton method. Right. So make it different. So I put as a second order, third order, and fourth order of the Adam-Moulton method. Okay. Why we learn Adam-Moulton method? Because we want to correct the Adam-Bashford method. Okay. From here, we learn about the predictor and corrector method. All right, predictor and correlate method is an implicit method. Now we learn already about the explicit, okay, to get the early data, for example, y0, y1, y2, y3. And then the next, to get y4, okay, we start using Adam-Moulton method as a corrector of the predictor method. Okay, so in this case, we learn second order Adam-Bashford-Moulton, okay, third order Adam-Bashford-Moulton, and fourth order Adam-Bashford-Moulton method. All right, so we are going to finish here, okay, for this a few weeks, okay. So we can also solve the types 2. What is a types 2? Okay, let's we go. Okay, the types 2 meanings that we are using a set of ODE. We learned already a set is a couple. For example, temperature in this room is just not just depend on the space and time, but also how fast the aircon in my room. All right. So now Euler method is a first order, second order, and third order. Okay, this is explicit explicit method. And then for the higher order, okay, of the EDE, ODE, we also apply Euler-Ranskata method, but we are apply how many times? 2 times, okay, 2 times because this is a set 2, okay, the set of the first order ODE, which is depend on X and Y, is depend on the M and N, okay, and then Y and X, okay, U and W. So it's a set, it's a couple, what we call twins method. All right, so now I think, okay, for your attendance today, okay, I just want waiting you at the solving a problem, how, okay, what is the difference between explicit and implicit. And then second is, we are now in ODE. What is different between ODE and PDE? I just want to make sure that, and the types of the ODE. The first is a equation of the ODE, first order. The second is a set. Okay, a set. What is set? Set is a combination between two equations, two derivative equation. For example, here, all right? For example, here. Okay, this is a set of the ODE where they combine, the couple, the twins between X and Y and N, M and D. All right, so this is the way how we represent the phenomena in the world right now. For example, raining is depend on the how many cloud, okay, how many cloud, okay, in this area. All right, so this is independent, okay, parameters, but we put in the two set of the ODE. Okay, so now let's we get a feedback from others. I'm waiting feedback from others at the link that I give you. All right, so I'm waiting from others who are give me more, okay, feedback on the difference between, okay, let's explicit and implicit. Okay, I'm waiting others to give me a feedback. This is considered your attendance, okay, your attendance for today class. And then second is what is different between ODE and PDE? What is different between ODE and PDE? All right, so I'm waiting you at the link that I give you here. All right, so please answer my question. All right, so I saw here Nurul Ain said that the ODE is a function based on the single independent variable. Very good. PDE is a function more than two, okay, independent variable. Very good. All right, so I'm also get feedback from others. Okay, for example here. All right, let's we share with you. All right, so I also get the feedback from a few students here. For example, from okay, Asri said that what explicit is a calculating the numerical method from the previous step, previous value, previous okay parameters, okay, or the variables, okay. And then what is the implicit? Implicit, you are using a current, okay, the current okay status of your grid now. Okay, for example, if you want to find y4, so you are using the y4 at the current iteration, a current time step, a current value. All right. Okay. However, to get the y4 at the current value, we have so many ways. Okay. For example, you can use like Craig-Nicolson method. Now we learning about the Adam-Bashford-Moulton method. Okay. So just about the terminology, you know. Okay. Next, we are going to learn. Okay, what is a Adam-Bashford method? How this method potential to beat with the Ranch-Kata method, for example. Okay, how easy Adam-Bashford-Moulton method to be more superior compared to Taylor's method and Euler method. So this is a just to beat okay the information. All right. So at this moment, okay, for me, I'm going to share with you, okay, after this, okay, because we just meet you in 1 hour. So I want you to share, okay, something I will send to the e-learning, okay, about this, okay. I want to share with you. I'm already okay prepared the ODE and PDE, okay, the ODE itself, sorry, the ODE itself. Okay, for example, how to solve ODE when you have the initial value problem. Okay, so what is a nature for one step, single step, multi-step method? All right, so I'm going to share with you after this for the next class. Okay, all right. Okay. Okay, keep contact me through the Telegram and the link that I give it to you now. All right, where is the link? Okay, okay, this is the link. Come on, go to the link or go to your Telegram. All right. Okay, bye bye. Thank you very much. See you. Okay, see you. All right. So I have Aziza here. I have Nurul, and then Intan, and then I have 7 2 view for this. And then let's go to your QR codes and the confirmation. Okay, voting for your QR code. Okay, bye bye.